So where we last left off, we were talking about the different causes of climate change and how Donald Trump has his logic when if he were to say that he said that climate change actually has been ongoing for years and years and years, that it has got nothing to do with humans. So we already addressed at the previous lesson what is his reason, his actual political, economic reason. Why is it that he doesn't want to admit that US should be doing something about it? But we also talked about the fact that there are natural things that's happening, right? We talked about, say for example, the fact that the sun is just like us, where it's a bit hormonal from time to time. And when that happens, there's a lot of pimples that are showing up on your face. And when that happens, also means it's the most angsty point in time for that person. So in this case, the sun, every 11 years they're going to have this magnetic activity where during that point in time it's going to be the most angsty, so you're going to see a lot of pimples on his face, known as the sunspot, but also the most angry at everything else in the world, where he is also releasing the most amount of shockwave radiation. So as a result, we end up with more shockwave radiation, meaning it will be hotter when it comes to days like that. Okay, the period in time that's like that. Okay, the example we brought about was here. Sorry, once again, I'm going through the wrong set of slides first. Okay, so this was where we left off. We were talking about the fact that the sun, when there is more sunspots, that means there will be a lot more activity, right? So if I remember it right, Joreen was the one who shared that similar peaks. Yeah, it happened to be at the same time where it's high temperature, this side is also quite high. But there is a difference, however. While Donald Trump was saying that, yep, there is sunspots, or rather he's not saying sunspots. I don't think he's that clever enough to even know what sunspots are. But the fact that he's able to say that it's natural, right? It does go up, it does go down. Okay, but the thing is, when it comes to the actual temperature, you can see there's a general trend that it is increasing. So while there is some truth that they will eventually go down, but it doesn't go down enough. General trend still shows an increase. Okay, so that's one. Okay, the next part of it, then we're going to go into the other human factor, the other natural factor, which is volcanic eruptions. Okay, I just breezed through the slides just now because my sequence is all wrong. But let's go into it. So you're already familiar with the fact that volcanoes will erupt. Okay, so if this were to be a typical face-to-face lesson, my next question will be, what are the things that's being released? Right? You're going to say dust. You're going to say ash. Okay, you're probably also going to say things like carbon dioxide, right, which is a greenhouse gas. And the fact that, you can come up with sulfur. Remember the one, I think I remember Niel's group was the one who researched on it or something like that. They come up with like sulfur as a whole big thing that they can extract from volcanoes, right? It will also release sulfur dioxide into the atmosphere. Okay, there is a particular reason why I'm bringing up sulfur dioxide. Why is that the case? Okay, so you can see here, when volcanoes erupt, it releases a whole bunch of stuff. But there are some that actually has an impact on the climate. So what are they? Say for example like this, right? If they were to interact with each other. Oh no, it's happening again. No, I cannot go through the next slide. Why is it always like this? There you go. So if you were to interact with each other, right, it will form this thing called sulfur-based particle. So if you're thinking, what the heck is a sulfur-based particle? Think of it as tiny little, the one where that time during the National Day celebration, Mr. Low pulled on that big bomb-looking thing that shot out confetti all around the school hall, right? That tiny little confetti, if you were to think of it in terms of microscopic scale, that is sulfur-based particles. It's like tiny little flakes of, those party sparklers, all that kind of things, right? It's up there in the atmosphere. And the thing about these sulfur-based particles, it is silvery, it is reflective. So think of it, how do you think that is going to affect on our climate? Right? The fact that there's this thing called sulfur-based particles. So yes, in your notes, it will be blank, so I want you to fill this part up. Okay, sulfur-based particles, if it's reflective, it's shiny. Okay, I think by now most of you can already come up with it. It's definitely going to affect shockwave radiation, right? In that it will reflect it away. And if it reflects it away, that means less to reach Earth to convert to heat. Therefore, temperature is cooler in a phenomenon known as global dimming. Okay, I ever once asked, when I first found out about this, right, I learned, last time the syllabus, we didn't learn about this till all the way, I think, in university or something like that. When I first learned about this, the first question that I asked was, so isn't this a good thing, right? We're talking about climate change as in getting warmer, right? So shouldn't we be releasing a lot more of these sulfur-based particles out into the atmosphere? Then in that case, our climate can get cooler. So the response was, in theory, yes, that would be good, but just like everything else, just like dust and ash from a volcanic eruption, eventually this will settle down. And when it settles down, remember we talked about how a volcano erupts, it will contaminate water supply. As the dust and the ash settle, same for sulfur. When it adds into the water, it's going to contaminate the water supply. So it's not good to have it. Yeah. Nevertheless, we're right now just talking about the climate. So the fact that it causes global dimming. So I want you to imagine, if a volcano is erupting at one location, how the heck does it affect the whole entire planet, right? Unless we're taking all the volcanoes in the entire world erupt all at one shot, probably means that's the end of the world already lah. But short of that, how does a volcano eruption affect an entire planet? Think, how does that sulfur-based particle spread? I hope you guys were able to deduce this. Because technically, well, simply put, wind will blow it. So as the wind blows it, it's going to spread out globally, and as a result, it's going to cause the entire global temperature to dip. Okay, think of it this way. In 1991, okay, I don't know how, you guys won't be born yet. I was like a few years old. But yeah, anyway, when volcano first erupts, right, it releases 17 million tons of sulfur dioxide. Tons, by the way, is 1,000 kilogram. Effectively, this means 17 billion kilograms of sulfur from one volcano. Okay, and the thing is, it will spread across the world within 2 weeks. So it takes time, but it does spread. Okay, and as it spreads, it lowers the whole northern hemisphere temperature by 0.6 degrees Celsius. If you're thinking 0.6, not that big a deal. Actually, it's huge. This is on average. That means some parts will decrease a lot more. Some parts will decrease a lot less lah. But those that are affected a lot more, they can go down to like 2-3 degrees Celsius. It's quite a big deal. Okay. However, it lasted only 2 years. Okay, think just now what I just said, right? Eventually gravity will pull it down. So it will settle, it will contaminate water supply and all that other stuff. But also means the effect on the climate is temporary. Okay, so I hope you can see when it comes to the natural causes, there is a pattern. Whether we talk about the shortwave radiation from the sun, the variation in solar output, that is an 11-year cycle. The volcanic eruption, that is like 1 to 2 years, the sulfur-based particles will settle. So that means all these natural causes, while yes, it has an effect on the climate, it will be temporary. Which brings us then, if it's going to be temporary, what is the reason why we are so obsessed with climate change now? It's because of the human-induced portion of it. Okay, so for this, you have a little bit of work that I want you to do. Okay, I want you to imagine this. Okay, this is our planet. Imagine this is the greenhouse effect. This is our planet. Okay, I wish I could see you guys face to face. I want you guys to distinguish between this and this. Okay, greenhouse gas, while we may think of it as something to trap heat, it is actually a good thing that it can trap heat. Why? Because if it doesn't trap heat, the planet is going to get too cold. We cannot support life. So greenhouse gas naturally formed should be there. It has to trap the heat. Okay, if not, remember like all those planets like Mars, Venus, it's relatively the distance where it can support life, but it won't because there's no greenhouse gases to trap the heat. Yeah, that means whenever the thing is facing away from the sun during night time, it's super frigid cold. Nothing can survive. Okay? On the other hand, human-induced climate change means a lot more greenhouse gases, meaning your blanket gets thicker and thicker and thicker to the extent where it starts to suffocate you. You're going to get hot inside there, and eventually you're going to perspire and you don't want to wear that anymore. And you will suffer in that. So that is what human-induced climate change is all about. Okay? So while the greenhouse gas is a natural process to trap outgoing heat, the enhanced greenhouse effect is something that is significantly worse. Take a look at this graph. Okay, this is a graph also from inside your textbook. Okay, so these are all the greenhouse gases: carbon dioxide and methane. Methane, if you wonder, these are like I don't know whether you guys do experiment in the science lab. You ever smell those super smelly one like ammonia? Methane is also equally smelly. Okay, but the thing is, it is 20 times more potent than greenhouse gas. More potent than carbon dioxide in trapping heat. That is how bad methane is. So we don't want methane at all. But if you can see from the trends here, okay, these three gases, it's happening again. Okay, these three greenhouse gases, sorry, I just highlight circle 2. These three greenhouse gases actually grew exponentially at this point in time. Okay, there is something that happened that caused this to suddenly increase, which is the 1880s. I think I went through that in class. That is the Industrial Revolution. where people started building factories. They started realizing that they don't just need to just grow crops and eat their own food. They can actually make things, and when they make things, they start burning fossil fuel for them. And when they do, that's when all the pollution starts to go epic. Okay? So this is what's causing the human side of climate change, right? That makes things worse than the natural cycle. Okay? Which means he's wrong. Obviously he's wrong. Okay? So for your lesson for today, I know that we're not seeing each other. Maybe I'll do a quick thing about what is fossil fuel, but what your work today is, you're going to research into, not say research so much, just read textbook. Then after that, go online, maybe hit one article about it. Alright? You're going to be talking about your cause of climate change. What do I mean by your cause of climate change? Your assigned cause. You're going to do a quick write-up and an annotated photograph. That is your assignment for today. Supposed to be done in class. So today. Then what's going to happen? You're going to share that Google slide with someone else who's going to comment on your slide. Okay, so let's take a look at what do I mean by this. It's under your Google Classroom, something that I just posted. Okay, there. Okay, if you were to open it, open with, oh there you go, it opened. Okay, so these are the causes of climate change. You will be working on only one of them. Okay, so I gave names here, so you know exactly which one you're supposed to work on. Okay, and the one that you're working on, you are also going to comment on. What do I mean by this? Okay, say for example, you are Ayuni. Okay, so Ayuni is going to be working on deforestation, meaning you read the relevant deforestation page in your textbook, you find one article with a photograph especially about deforestation, then after that, you write about it. Then you share your slide, because it's individual, right? You share your slide with Joey. Then the homework after today, between now until Thursday, I'm not giving you any other worksheet, right? So Joey is going to comment on your slide. Joey is going to comment on Ayuni's slide. Easy, right? Okay, so I'm going to tell you exactly what do I mean by comment on. Okay, so this is what you'll be asked to do. Okay, I asked you to, again just now, right? Read your textbook, relevant pages, find one additional source, fill in the table here. Right? Just tell me what's the name of your factor, what is the definition of it, and how does it contribute to greenhouse gas. Give me at least two. Okay, don't just give me one. And give me the details of the process. For example, deforestation, there is the photosynthesis, and there's one more process. Right? This thing called soil oxidation. No one will know what the heck soil oxidation is. I want you to write down what the process actually is like. Okay? Then, I want you to come up with your own logical thinking. Why is it likely to get worse over time? Textbook won't have it. I want you to think, why is deforestation going to get worse? Why is agriculture going to get worse? Whatever it is. Okay? Then the last one, I want you to support with one example. Short one, please. Don't tell me you're going to write a super long paragraph here. Don't copy and paste, please. All I want is just a name of a place and some relevant details like a statistic about it. Okay? Write it down in this last row. And find one photograph from the article, add annotations to it. Okay, then after that, that will be your assignment. That's it, just 2 pages only. Yeah, then your homework after that, after today, is you'll be commenting on someone else's one. So like just now, example, Ayuni's one, right? She will share her slide with Joey. Joey will come in here, then after that, write down below. So Joey, I think Joey is going to work on, I can't remember, urbanization, I think. So I think my assigned factor of urbanization is more significant than yours because whatever it is. Okay, so I want to see, it's like an essay conclusion paragraph, you know? Okay, so that's it, that's that. So that's a very short video, less than 15 minutes. Please make sure you watch this video finish. You do your activity, settle it by today. I know I gave a timeline here of 3 p.m. 3 p.m. by today. But honestly, it's because I also thought we're going to see each other face to face. So the fact that we're not seeing each other face to face, I just realized that you guys are all on HBL. So I'm giving you an extension till tonight, anytime tonight. Okay, just once you're done and you share the file to your friend, please message your friend so your friend knows that, oh yeah, okay, then that means now I can go in to comment on their slide for the homework. Okay, so anytime by tonight, I will be checking on that. By tomorrow, if not, then you stay back and do with me. Okay, alright, see you guys, have a good HBL day.